Get my fan all situated here. The one fan of my show. Yeah, I never be old. We're live, and tonight we're going to talk about turbo stuff, which is one of my favorite things. And we're going to talk about 5-liter Ford turbo stuff, although the turbo stuff that we're talking about applies basically to all of these things. So the interesting thing is I was looking back through some data, and we have some turbo testing on small block Fords, and I ran one basically on a stock motor or stock HO, fuel injected 302 that made, they usually make between 250 and 260 horsepower NA. And I've run lots of them. We normally run them with headers and some sort of standalone management system and stuff, and an electric water pump and things. And that's kind of where they are with it. If it has a stock intake and a stock throttle body, the HO upper and lower deal, stock E7TE heads and a factory cam and stock short block and all that stuff, that's kind of where that they are. They're rated at 225. The way that I test them with headers and no accessories, no aero and stuff, they usually make about 250 something, 260, right in that range. And then what I did was we ran boost on the stock one. So we made, we wanted to push this thing over 500 horsepower, which we did later on also in modified form. But in stock form, this thing at 14.4, 14.5 pounds, it made 521 horsepower, 522 horsepower, right in that range. And so it did good. It did exactly what we thought. As what I did was ran the thing NA, make sure the motor's okay. Then we added a small turbo, a single turbo with an intercooler. In this case, it was an air-to-air. We could also run air-to-water, which we've done, which we did on the other one. So it's the same kind of deal when we were running at these kinds of boost levels and these kinds of power levels. We didn't have any sort of flow issue with the intercooler. And in terms of cooling, we do cool down for the runs to get any residual heat soak out of an air-to-air. But we also ran a modified version of a 5-liter, so one that had heads, cam, and intake manifold on it, and it had airflow research heads on it. It had a good cam in it, that 274 cam or something like that. And then this one I think had a ported, not a ported. It had a RPM 2, I think. Bigger throttle body and headers and all that stuff on it, and then with rockers on it, and it made just over 400 horsepower, 402, 403 horsepower, and then we made over 600 horsepower. So did a similar thing with one with RHS heads and a ported. This is why I was thinking we had a ported one, a ported Systemax intake manifold, and so whatever intake manifold you're going to put on there, whatever camshaft, all that stuff is going to help dictate the power. But if you're near 400 horsepower, we made over 600 we ran this one at 7.9 pounds and it was 618 horsepower. But the thing that I want to talk about is if we look at how much, a lot of guys talk about power outputs with turbos in terms of how much horsepower they make per pound of boost. And that's important. That's a good metric, and it's an easy way to measure it. I mean, it can be argued, I think, if you look at it, it's kind of a bell curve. So the first pound of boost might not add more. The middle pounds of boost may add more than the first pound of boost does, and then later ones where you're getting up near the flow limits of stuff may add less. It may add more temperature. It's never just like a nice linear equation where everything works out exactly the same. It's never like that. And so, but one of the things that we can do is if we compare this, we see that on the first combination where we ran 14.4 pounds and we gained about 250 horsepower, we're looking at 16 to 17 horsepower per pound of boost. So not a lot, but again, the amount of power that we make per pound of boost is a function of the NA power output. So if you're starting with a lower power output, we just don't make as much. And then on the next combination, going from 400 to over 600, we made 160, 40, about 25 pounds of boost, or 25 horsepower per pound of boost. So in the second combination, we made more horsepower per pound of boost than the first one. So the question becomes, which that has everything to do with the turbos, and this is the mentality is that one of those turbos definitely has to be better than the other because it made more horsepower per pound of boost. The reality is that that's the same turbo used on both of them. And that's kind of what I want to talk about tonight, is the fact that if you get a turbo, they usually, particularly in this V8 range, they have a pretty broad range of like usable power output. It would not be unusual at all to get a turbo that could make 400, 500, 600, 700, 800 horsepower. Get the same turbo that can do all of that, and be fairly effective at it. Yeah, I mean, guys want to nitpick and argue that, oh yeah, if you were making 7.8 pounds and you were making this much boost and this much power, and that there would be one turbo that you could put on there that would do better than all the others because it would be at its maximum island efficiency and all that. And that's all fine. If we want to go down the engineering path, we could talk about that, because actually I would argue that point again. Because if you wanted to talk about a stationary load and then get the lowest charge temperature from the most efficient turbo that you can put on there, that's something. But then how does that affect boost response for when you're actually using the turbo and not just sitting there like pumping your irrigation pump, using your motor to pump your irrigation and pump water, where it's sitting at a fixed, amount of boost and RPM and load and all that stuff, because that just never happens. So this dynamic equation where we want the turbo to spool up, what do we do? And in this case, looking at the horsepower per pound of boost is not really a very good metric for that, because, as we said, the reason that one of them makes more than the other, it's the same turbo, so we know it's not a turbo situation. Again, guys are going to argue, well, but you're at a different part of the map. That's not it. The answer is right in front of us. It's the fact that we took our 250 horsepower motor and put heads, cam, and intake on it and made it a 400 horsepower motor. So now every pound of boost is worth way more. The turbo does that all by itself. It becomes more efficient at every pound of boost. The turbo doesn't change. It just that now it's processing more air with each pound of boost, and you're making more power. Also, obviously, this happened at a lower boost range. So lower boost, lower temperature. We're running through an intercooler anyway, which is negating a lot of that change. But it's still better. And so in this case, these are both GT45 turbos, which is cheap and it's inexpensive and reasonably well. And again, I'm looking at the big picture here. The big picture is that if we put a turbo on it and we don't have leaks and we have the tune right and we have all that stuff, it's going to add a lot of power. But if you're thinking that you're going to put a Super Magic turbo on there on a stock 5-liter Ford, or a stock junkyard 4.8 or whatever motor you have, or a 2J or whatever it is, and that somehow that turbo is going to be like so much better than everything else, particularly at these lower boost levels, that's not going to happen. You're not going to get that. If you run 7.5 pounds on one of these and then you go find another turbo, find me another turbo that makes 100 horsepower at this same boost level, and I will be very, very surprised. I just won't believe it, because it's not going to happen. So the boost thing is the big thing, the boost and the NA power output. And then obviously, like I said, people talk about turbo size. Yeah, the turbo's got to be sized for what you're doing. Yeah, but this is a 400 horsepower turbo and a 500 and a 6 and a 7 and possibly an 8 if you have the right small enough motor and the right combination and stuff. It has the potential to do that. So it can work in all of those. Is it going to be like ideal in all of those? No, but is it going to be good enough? Is it going to be like 95% there? Yeah, it is going to be there. And so when we're talking about these turbo efficiencies, the other thing that I wanted to talk about is that when we're using this turbo, which can also do, let's say, 700 or 800 horsepower, we know that because we've done that before on this GT45. How does it work when we're trying to take our 250 horsepower motor and make 400 or 450 or 500? Why does it work doing that? And how responsive is it going to be on this less powerful combination? Well, the answer is it's actually going to be fairly good. And in some cases, depending on when you're having the boost come on, it might be better, because the lower horsepower motor combination may actually have more torque at 2,000 or 2,500 RPM, where you're asking this turbo to spool up. And that's one of the benefits of using this on the benefit that like this 5-liter motor has, or typical American V8s. A Cadillac would pick, a 500-inch Cadillac would be a perfect example, where it makes way more torque than it makes horsepower. An L98 tune port small block Chevy, another good example. So on this 5-liter Ford, same thing as a tune port Chevy. It's making 300 foot-pounds or 320 foot-pounds in our case, and 250 horsepower. So it's making way more torque than horsepower. So it's still going to do that with the turbo. But the nice thing is it's making enough torque to spool this turbo up. And so you can get, if you want 7 pounds, you can get 7 pounds down low and have 7 pounds all the way across. 7 pounds doesn't help us on the big end as much as it does when we have a 400 horsepower motor, because we're not multiplying that amount, but we still have the response rate because we have enough torque to generate that. So that's the nice thing about having a big American V8 is that we have better spool. Even if we're talking about a stock one and not making very much peak power, we're making pretty good response because it's big in displacement. And then when it's big in displacement, it offers lots of low speed power, which is, in my opinion, the single biggest thing that's going to determine the response rate of the turbo. The second thing, or equal thing, is turbo sizing relative to this power output, this low speed power output. But those are the things that are going to determine that. And big American V8s kind of have that in spades. And that's what helps this turbo. It helps this dynamic range of the turbo, because we can get spool up in the lower power level. So we still get pretty big torque numbers. But if we want to go from 250 to 400, we can do that and still have it be fairly effective. And then we could also do 500, as we showed, with more boost, 14.5 pounds. 500, 600, 700, and on up. The hard thing to do is we can't take a 250 horsepower turbo and also make it a 1250 horsepower turbo and have that sort of range. That becomes a bit more problematic. I think as turbos are getting better now, that what's happening is, and we talked about this a little bit today, is the trick that they're doing now with getting rid of the big nut that's on there so they can get more airflow through the same size, dimensionally sized impeller wheel. That what they can do now is they can broaden this range of like available power usage for the turbo. It can flow a lot more. It's still small enough to be responsive down low. It can flow a lot more. So now we've added, so instead of a 600 horsepower usable spread, whatever that is, maybe it has a 7, or maybe it had a 5 and now it has a 6, whatever the numbers are. It increases that by making the turbo, by making that same impeller wheel flow better, making the turbo more effective, more efficient. You can label it however you want, but it's going to make that more responsive. And then the other thing, or the range be much greater. The other thing that it might do is it may make the efficiency greater too. So within that range, we may have a little bit more power at 8 pounds, a little bit more power at 9 pounds or 10 pounds, or wherever that thing is going to be efficient at. It may have more power there also, that's nothing but a good thing, right? Because it's good that particular modification I was talking about does get rid of some of the turbulent stuff. So the turbos do this, like I said, not just with this 5-liter Fords or these 5-liter Fords that I tested on, but also we see this on small block Chevys and small block Fords and big blocks and LSs and Dodges and all of these things. This, determining how much power the thing makes per pound of boost, and then the response rate, all this good stuff. This is why it's so easy to make power with, all the junkyard stuff that we deal with. Let's see what you guys got going on. Winston, Rich, Getaway. What size turbo for this generator? I just bought because a hurricane's coming. Uh-oh. Special agent. Turbo generator build would be awesome, Sean, especially if it's a diesel. Todd, you got your LS2 running. That's cool. Sammy, thanks for saving me time and money. Happy to help. 78.75 all day. Yeah, that's a good one. That's the 9, depending on what generation it is, 900 or 1,000 and below. Works good. I was wondering, should I file my rings on my 4030 or 408? I'm going to be using 300 to 400, 350 to 400 shot of nitrous. The pistons manufacturer's piston to wall clearance is 6.5 thousandths. It's a forged piston, then they got a lot of growth on them because of the nitrous instead of 5 thousandths. I would still put 6 to 6.5 per inch of bore. The answer is a Pro Mod turbo. It'll spool eventually. Yeah. V8 is more about packaging than a turbocharger. So yeah, 6.5 thousandths per inch of bore. The best turbo you already have, and if you want the best turbo, get the one that does work best for what you want to do at the most responsive with the least back pressure. Okay. Modern turbos make a real difference only at higher boost levels, definitely above 23 to 23 psi. Yeah, there's a lot of good ones out there. Probably most of the people watching this are not getting those turbos or getting inexpensive ones, but so Todd, have you done some tuning on it? An LS1 Tech with a 6-liter single turbo making 800 on pump in a truck or Tahoe. We tore the engine down after 80,000 miles and inspected and found no excessive wear. That doesn't surprise me. If the thing's tuned right and it's not detonating and you're not getting a lot of blow by where you're getting contamination in the fuel, like you might D85 or certainly with methanol, where you could, you'd be more likely to wear stuff out with that if you let it go too long without changing the oil. But I don't think that that's too hard on them. As soon as I get the break-in miles, we do hot laps around my block. If a GT45 and a 7875 both have a 75 millimeter exducer on the turbine, and if they both had identical ARs, 8.6 in theory, they would both have the same response rate and back pressure. Not if they're connected to different compressor wheels. I've done that test where we use the same hot side and change the compressor wheel, like going from a T3 to a T3 T04 kind of thing, and it changed the response rate. We tried doing that with the guys from Turbo City way back when after I ran all of the different ARs on the T3 turbo that we had from the T-Bird and the SVO Mustang and stuff. We ran a 48, a 63, and an 82 AR on the T3 turbo that we were running. And then the next test is we were like, okay, we made like 350, I think 340 at the tire with the little Honda motor. We wanted more turbo. And so I think it was the guys at Turbo City back in the day, because this was a long time ago. They had a T3 T04 turbo. I think that they probably had for, I'm guessing it would be for a Grand National. And they said, yeah, this cold side will flow a lot more than that T3 turbo that you have. And so we put it on, and this thing did not want to spool up. It was just soft the whole way, and never did better than the T3 did. The cheap turbo is the best one. If it does break, you spend $200 to get a new one. Yep. 8,000 miles at 800 horsepower on pump is impressive. That is. So if I'm understanding, 6.5 thousandths times 403 equals 27. Yeah, that's enough gap. But you're breaking in a new high performance motor. We do any new motor that we put together that has new rings in it. The bearings are not. I'm actually not that concerned about breaking in on the bearings or the camshaft on a hydraulic roller camshaft like on an LS. But rings, we give the rings a chance to seat. And so we send them through a break-in cycle. And always on a new motor in my cars, I've always broken those into. Todd, tell her I said, hey, have you run ID 1300s? I don't think so. I think the only big injectors I run like that are some Snake Eater 1500s that I have. Just out back porting and polish some 862s. Nice. How do you break in rings? You give them time to seat and get acquainted with the bore. I like to look at all the modifications as it relates to power and percentage. The real question is, how much do I get my NA 331 ring so I can accidentally add boost in the future? You put the same amount of gap in them. You just gap them for boost. It's not going to hurt. It's not going to hurt anything. Or I should say that when we've done ring gap on LS motors and done 6.5 thousandths per inch of bore, it didn't change the power output at all. And these are on motors that had questionable ring seal to begin with because they had lots of miles on them. Maybe it was all leaking past all of the ring and not just the added gap. Maybe that was the issue. What supercharger can I put on an L96? There are lots of different superchargers. Magnuson has one. I don't know if Kenny Bell still sells one, but Whipple does. Torque Storm does. Vortec does. There are lots of them. So higher back pressure equals quicker spool response time, but then obviously limits the sealing power. Yeah, it's a delicate balance between the combination wanting to have boost response and peak power. The ideal situation is to have all the boost response that you want, and then have the flow rate of the hot side and the cold side limit at the same power point. That's hard to do though. What brand rings do you trust for turbo setups? We always run the stock ones. I don't have all my stock ones. You can get Hastings makes stock replacement ones, or we get Total Seal stuff. If we get good rings, we get Total Seal. Personal care is effective and appreciated in spoken chatting. Do you want to elaborate on that, or? Oh, you're thanking the chat people? There's lots of good chat people here. People are people. Bigger the compressor wheel relative to the turbine, the slower it builds up boost, and the sooner it drops off. Can you put the LT4 on an L96? Isn't an LT4 an LT1 base motor? And that intake manifold is going to be completely different than an L96. There might be a way to adapt that blower to an L96 while opening up ring gap affecting the engine's ability to pass mod. I would think that it would. Have you ever tested on-3 kits? I've not, but I haven't tested a lot of kits, like dedicated kits for applications, because they normally don't fit on the dyno. Empty pockets. You should be able to turn that turbo all the way up to the limit of the turbo. My L3 kits have been terrible for small block Fords. Was it a fitment issue, Tim? The fan sounds like a lazy plastic rattlesnake. That's what it sounds like in the mic. What budget turbo would you recommend for a twin setup on an LQ9 with ported 317 heads? You got to tell me the desired power output, and then we could size the turbos accordingly. Do we do the top and second ring the same? Yeah, not the bottom ring, but the first and second ring, I do them the same. So, this famous last words. So if I get it right, if I get the gap right between 27, 28 thousandths, I will have no problem with a 400 shot of nitrous. I didn't say that. I said that you won't have a ring pinching problem with a 400 shot of nitrous. But since I don't know anything about your tune, how it's being applied, you know, is it being progressive? Is it hitting all at once? What, you know, I don't know any of that. And then is 400 shot, what is the 400 shot as a percentage of your NA power output? Because that's the first thing that would concern me, is that you are trying to have the motor process too much, and it won't do that. If you have a 400 horsepower motor, you're not going to be able to run a 400 shot of nitrous. Bad fitment and low quality parts. Okay, for the on-3 stuff, both kits were even missing parts. I can't GM come up with a new engine designation. There's no reason to call it a double overhead cam 4-valve and LT. They're continuing on with their marketing. You want 12 to 1400 horsepower. Well, if you're doing 14, then I would do 2 GT45s. The other thing you could do, you could talk to Viren about that. He probably would have recommendations. Maybe 366s might get you there. I don't know if they'll get to, maybe they would get you to 14. Is a divided housing on a T4 base turbo better for response or spool, or both? The response and spool are the same thing, so it would be both if one is better. And the divided housing itself might not be, because we run divided housings on open T4, T3, or T6 flanges all the time. But if you had each side go to them, I'd like to see that test to see if that does anything. I have a hard time wrapping around my head around, without going to the actual firing order, how half of the motor is going to be better feeding half of the turbo than all of the motor feeding all of the turbo. I don't know how that, the math doesn't work for me like that. Maybe it's a pulse thing. Like I said, if we didn't go into doing the exhaust for getting some sort of, you know, pulse frequency for the turbo, otherwise I don't know how that it's going to change that. Fossil fuels, you have a 2000 Explorer 5-liter and want to go carbureted with a 470. Is it possible to use the stock PCM to run the trans? Does anybody know that? I'm the wrong guy to ask that. I don't see how that will work, but maybe there's a workaround for it. I'd like to see the results too. I've only run T4 open. Yeah, I've never separated both sides of the exhaust, and it seems like if you separate both sides of those exhausts, that you have to pinch them down for the size of the openings that going into the turbo, which they're going to pinch down anyway, but, you know, I have questions. Appreciate the content and the work that you put into the videos. I look forward to watching your stuff. Thank you very much. I'm very good at nitrous tuning. I made my stock cast crank with forged pistons the last 12 years. Nice. 800 passes is a lot. A 250 shot. How much timing were you taking away on the 250 shot? The general consensus anymore for a lot of these big hit nitrous guys is they're not running them very rich. Richard, do you have more coming on the 3800 V6? Yes. Or LCX turbo. I don't know what that is. All forged internals and so top and bottom H-beam rods. Would you ever considering a DIY turbo test or provide a test recipe? I think a compound setup on a 4.8 could be interesting. I already ran a compound turbo setup on a 4.8. Those videos are already up. I did 4 or 5 of them probably. It's by no means ideal in terms of compound stuff. It's just 2 turbos that I had laying around, one going into the other, and one being a little bigger than the other one. First step for someone who knows nothing about engine building, do you recommend a certain book? There might be books on how to build stuff, but there's so much information online that you can do it for free. You can just do searches on how to build a motor for the first time motor building. Any of those, search subjects should bring a ton of stuff out there. 6 degrees retard running Q16 on a separate fuel system. And was the rest of the fueling for the motor pump gas or something? Do you know of a cheap 8-channel EGT K-type reader? Want to do boosted CIS setup and don't really want to blow it up? I don't know of a cheap setup, but who do we trust on a search? That's the thing about going and finding information. It's just like finding political information. You have to go to, you don't just go to one thing and it tells you the answer. If that's what you're looking for, that's not out there. Nobody that spent 20 or 30 or 40 years building engines or doing dyno testing or playing tennis or golf or anything went and learned that, like typed something in and just said, oh, okay, now I know that. That's not the way that happens. Searches don't happen like that either. You have to go and find one and read it and go, okay, well, this one said do this. And then I went and read another one, which you should read lots of them. And this one said do that. So now I'm confused. That means you got to read more. And then you got to get a general consensus. And then you could come on here and ask questions, and then we could give you hopefully more information on what those questions would be. And because a lot of guys, if they've done, magazine stories, or especially now, guys doing their own internet things, YouTube channels or whatever, they're doing their own things. They're going to impart their opinions in part of these things. I do that. I'm guilty of that. I try to provide dyno information. Guys ask me my opinion on stuff, and I give them my opinion on stuff. And that's not an absolute. Any opinion is not absolute. I wouldn't expect everybody to like Nash Metropolitans. I was hoping to continue the conversation from the last live. Was wanting your opinion on a better cam than an LS9. Almost anything. When considering less low overlap to avoid exhaust reversion and detonation when using pump gas. Do you think that the LS9 is the best choice for detonation control? I've been binging all kinds of videos. I've yet to get my hands on something. I think that's the only way to really learn them. I mean, look at how to measure push rod length. The way that I do it is the way that makes sense to me, because the way that I do it, I can do it on every motor that I'm running while I'm doing the rocker swap or the cam swap or anything. I can do it while that's happening. So for me, it's very efficient. Other guys want to use, custom tools and push rod checkers and all of that stuff. And I'm not saying that that's wrong. I'm saying that this is the way that I learned it. Steve Brulé and I went round and round with a lot of this stuff. Particularly, I can remember hooking up throttle linkage. I'm like, look, I'm just going to run this piece of wire, this piece of baling wire, or better yet, the safety wire, and I'm going to hook it to the throttle linkage. I'm going to run it back. We got an eyelet on the throttle thing. I'm going to wrap it around. I'm going to spin it around, and then look, there, it's done. And he's like, well, you should really do it like this. You should do it with this cable that has the eyelet on it, and then the eyelet goes into the eyelet receiver on the throttle linkage, and you could go back. And then I built this adjustable thing for these, and so you could do it. I'm like, look, that's fine, and that's your thing, and that works for you, and it looks a lot better than what I'm doing, my Super Richie drive-by-wire. But the reason that I did mine the way that I did it is because I started out doing it that way. And it's very, very fast and adjustable for me, changing the position of the throttle linkage setup because I run so many different intake manifolds and stuff. And so it just goes on and works, and it's fast for me. And that's what I'm looking to get done. I don't honestly care about how it looks, but like I said, he's right, and I'm right. And hooking up a carburetor linkage with the carburetor plate on there and hooking that up, that's right also. And so people can, there's lots of ways to, and you'll find that out also, that if you go down these rabbit holes and you're looking at all these things, you're not going to find, you might find something you think are wrong or whatever, but you also might find different ways that are all right. And maybe you'll come up with your own. That's the good thing about going down these rabbit holes and learning all this stuff and go, you know what? If I just did this, this would be better. Like when I went out to do stuff with James, when James was there, James Short, and with the guys from Brian Tooley Racing, and they had made a two-piece front cam cover, which has been around forever, but we couldn't get the cam out. But what they did is notch their damper. And so they just ground it down so it has to be oriented properly, and they can just slide the cam out, slide it back in. I'm like, and then they also had, which we'd been trying to do for a long time, but I just never made the things. They made it so that also you don't have to take the water pump off, which is just genius. That's way better. I'd been doing it my way, and I was really fast. I mean, I get it in, I don't know, 20 something minutes, do the cam swap. Their way was a lot faster. I'm like, and it never occurred to me to notch the damper. And I didn't, we thought about putting a smaller damper on, which I told them about. I'm like, look, ATI makes a damper that will just clear, because that's a truck damper that they're using, which is fairly big. I said, they make a different damper, but they said the same thing. It came to the same conclusion that I did. And that's that, well, then we have to have that dampener for everything that we test. And we test so many things that, there are reasons why you go down paths that you do. And a lot of guys come up with the same answer. To make out, we have a sticky for each engine build on LS1 Tech. Yeah, pump gas mix with 110, leaded, 3 parts 91. Okay, so you have a little bit of good gas also in there. Engine Master is a good learning platform. Yeah, they test very specific stuff, and that's cool stuff. You give us more feedback than anyone else. Yeah, there is some of that, because I know that there are lots of popular channels where guys don't even engage with the people. A lot of them don't answer questions, don't answer comments and stuff. I try to answer everything. Interesting in hearing about a dry sump setup for the LS, maybe walk through or install or talk about different stage options. That's a pretty expensive thing, unless you're adapting the LS7 deal or the one that they use. So I guess they also put it on an LS3, which I didn't know about until I was doing this live feed. So somebody told me about that, because I'm not a Corvette guy and didn't know that they adapted that GM used that. Dry sump stuff is really expensive, but it's really, really good. It's just that guys that go to a wrecking yard and get a motor are not going to put a $3,000 or $4,000 or $5,000 dry sump setup on a $500 motor. That's just probably not going to happen, even though it would be really good. Putting a 350 small block Chevy and an 83 Camaro. Okay. C28, nice. With an 86 350 that needs a lot of machine work. I was told the lifter valley's cracked on the 86 and 87 models. Should I just buy a crate motor? No, you should go to the wrecking yard and get an L31 from a truck, which there'll be a bunch of them there. And that's a Vortec headed motor. Put springs and a cam in it and a carbureted intake manifold and stuff, and just run that. The larger LSA and all my small snowmobile race motors would hold up way better against detonation resistance with lower octane fuel, also keeping higher PMs for long periods of time for road racing. Okay, that's all good. If you're making more cylinder pressure, I would imagine that you would be getting closer to the detonation window, which these cams will do, because if this is still about the LS9 camshaft, the LS9 is very soft down low. It has a really wide LSA, and what they did is they're letting the blower do all of the stuff and letting it make all the power, and then making the cam more efficient at the top, where a roots blower, a positive displacement blower, is not as efficient. And also, they wanted to be able to have on that motor, they wanted to be able to have good idle quality and fuel mileage and drivability and stuff. I honestly haven't tested, nor have I seen any data on the detonation suppression of that, other than it being as it would be related to cylinder pressure. The amount of times I've used a bike brake cable and just creased the cable after putting it through the hole. Yep. Yeah. Slicks front and rear on the 944 LS will definitely need a dry sump. Yeah, those cars handle really well. And if you've got an aluminum V8 in there, it's going to be cool. Interested in stacked boosted intervals of concentrated concession flow resulting in powerful wheel speed and gearing converting lockup in a is yours still the question about the compound boost deal? Forgot to mention I'm running a carbureted intake of the Sniper EFI, also considering the latent heat of vaporization rate. Having fuel go through there and the power gain that we get from that should also help with suppressed detonation. Because a cooler charge air should, because the cylinder pressure is not the only thing that determines detonation. Air temperature can, water temperature can, cylinder temperature can, which is also a function of pressure that's happening in there. But if you can lower the charge temperature, you can at least adjust that part of the equation. Because sometimes when you lower the charge temperature, you add cylinder pressure. How does it do that, Richard? I love my dry sump. Yep. There are people in drift cars going to dry sumps on iron blocks. I would definitely do it on a drift car and a road race car too. Papadopoulos is good to learn from. Yeah, Steph is good. Richard, what to do with my breather holes and my valve covers? Most people, what we do is we run lines back to the back of the turbo and just let it breathe atmosphere. Most guys in the car run them up to a catch can with breather elements on it. I wonder how much dry sump actually frees up horsepower versus a traditional pump. The dry sumps almost always make power compared to a wet sump. It gets rid of all the. It should get rid of all the windage. The only thing that doesn't get rid of is the way the oil's draining back down onto the crank. But it's not grabbing the oil in the pan and doing this cyclonic action. Have you ever used an 83 to 86 GM ECM, which is knock sensor retard device for distributor ignition? I haven't. I don't know anything about those. I have used on an 87 Chevy Sprint Turbo a vacuum advanced boost retard distributor. What's the learning curve like when switching from E85 to 93 on supercharged high compression EFI car? I don't know what you mean by the learning curve. You're just going to have to run a lot less timing. The only upside we've seen so far as longevity advantages and drag strip applications is during the shutdown. You see no difference up front nor an ET change. Is that the dry sump thing that you're talking about? I'm a big fan of breather holes to a catch can. Yeah, if you run a catch can, the catch can has to vent to atmosphere. I would be surprised in drag racing if a dry sump on a big block wasn't worth 30 or 40 horsepower. We know that because we know from just adjusting even on a stationary dyno, which the drag racing is going to slosh the fuel, is going to slosh the oil. But even on a stationary dyno, even having the oil filled to the recommended level by the pan manufacturer, running less oil in those makes more power. I need a catch can on my LT4. I really want to hook up a catch can on the dyno. I have just run the lines back normally. Rotary gets you a built-in dry sump. I hope you can make a video about finding ways to reduce back pressure with the same turbo. Then we would have to look at other things that are creating that back pressure. Besides it, usually the turbo is the #1 thing that creates back pressure between the turbo and the manifold, because the turbo sizing is the single biggest thing. I've had camshaft experts argue with me that the cam timing does that, and I'm like, well, when you're doing this change that you're talking about, and you're talking about a camshaft affecting back pressure, I said, did it change the power output? Did it change the NA power output? Well, I don't know that because we didn't test it. I said, well, I can almost guarantee that it did. So if you increase the NA power output, you have more exhaust flow because of the camshaft. It's not a cam timing thing. It's a cam power thing. It's an exhaust flow thing. So if you have more flow and the same restriction, you can therefore have more back pressure. I'm not saying that you can't also do that with cam timing, but that's the first thing that I would look at. And then you could also look at the sizing of the exhaust manifolds. If that's a problem, the sizing of the exhaust going to the turbo, you could look at some things. Worrying about the power change on 10 pounds on newer E85 and maintenance before the season ends. Shows how to use that module with multiple different setups. Cool. So there was no ET difference. So did you guys dyno test that, or did you just test it at the track? Did you make other changes besides? Because this is the other. I don't know what you guys did, but this is the problem that I see more often than not. 99% of the time, somebody tells me that this didn't do anything, and then between them doing this, like the test that they're talking about, and doing this, there was lots of other things that happened in here that changed also. And a dry sump would be one of those things that would concern me, because nobody is going to change from a wet sump to a dry sump at the track. That's just not going to happen. It's going to be another day or a week or a month or whatever and it's going to be a change in a lot of things going from a dry sump to a wet sump. That's not a quick bolt-on thing unless everything is already done. I'm in my Dodge van. The oil sump and pump are on the back of the engine. I've never had an oiling problem with lots of drag racing. It sits way down behind the K-frame. Yeah, some are better for that. Some of them have, windage trays go a long ways, and then baffling in the pan go a long way. For cornering, obviously, the kickouts on the pans, all of that stuff is beneficial. VS Racing 7875s on a built 5.3 with all the mods. What kind of power do you think that this could make? Well, 7875s Gen 2s will support, let's say, 1,000 horsepower. So you can make 2,000 horsepower if you want, if you had 2 of them. But unless your fully built 5.3 is a different kind of block, and then I don't know why you just do a 5.3. But just a 5.3 with forged rods and forged pistons is not going to be a 2,000 horsepower motor. At least it's not going to do it for very long. More money than the God's race team switch dry sumps at the track. But that's not a test that you do at the track. Other than, I don't know what you would want to know. Having a motor that's a wet sump and then doing a dry sump on it, and not running that at the dyno, I don't know why you would do that. And if you wanted to find a difference, that's where you would find it. It'd be a lot easier than doing it at the drag strip, than doing that involved of an oiling system upgrade at the track. Because if it shows at the dyno and you don't show it at the track, something happened between the power gain and the acceleration. It's not a real world versus not a real world. Something else happened. If you gain 20 horsepower, you should see a 20 horsepower difference. If it's 20 horsepower on 1,000, you know, it might be nothing. And do you have the ability to run exactly the same ET and mile an hour down to the thousands every time? And then you make a change, then you can see what that change does. If your ET and mile an hour vary by 2 or 3 or 4 miles an hour and a few tenths, and you're looking for a change that's inside that change window, you just don't know if you get it or not. Is it even possible to keep heads on a 5.3 at 2,000 horsepower? Yeah. Maybe the right heads on the right block and with hoops and all that stuff. Maybe that's probably possible. $30 to $40 horsepower makes a lot more sense. I was thinking like 100 to 120 on a dry sump setup. No, it's not going to be that. What turbo you like for 750, 800 horsepower wheel on a 5.3 sloppy stage 2, 3,500, 6,000? I don't know. I'm not in that range. I would be above that or below that. That's in no man's land as far as I'm concerned. A 7875 would be right there. Would be good for that. But I would be leaning more toward the 1,000 horsepower S475, S480 stuff, particularly with that. I'm assuming it has a stall converter in it too, right? Used to run a dyno cam's SS93 cam, my 5 horsepower Briggs flathead. It was called the cheater cam because it had stock lift and long duration. Yeah, if they're for like class racing where they're only checking one thing, you give them the thing that they check. Do you have any experience concerning actual cylinder pressure versus octane? I don't. Not because we don't have the ability to have in-cylinder testing. And when they do octane testing, it's on a single cylinder compression motor. They're not running a motor on the dyno. They're just adding pressure mechanically. Detonation wave simulation software. Okay. I'm thinking if you're shooting for 2005-3 isn't the foundation. Yeah, I would agree with that. Certainly not a stock block thing. Yeah, so Tim, yours is a 3,000 stall. That should be enough. That's probably the right stall for a sloppy stage 2. So that just give Byron a call on a 7875 is probably the way to go for that range. 3,500 to 6,000. That's not the cam I would pick for just going to 6,000 in a 5.3 though. I would pick a smaller camshaft. And if you have a truck intake manifold, I would pick a different camshaft. What sucks in my 75 Dodge van, I can't put the engine in completely assembled. It will hit the dashboard, so I have to put the short block, put it together in the van. Oh, that's a bummer. My cars only have stall if I mess up manual shifts. Thank you very much for what you do. Happy to help, Steve. I'd love to see an LS with a dry sump stock bottom end and NASCAR heads and cam and see how long it will last. Nobody that I have ever seen in NASCAR runs an LS motor. So, but if you want to look at, you want to do a longevity thing. Okay, I thought you were talking about like making lots and lots of power. As you say, drag race guys are making lots and lots of power. Even on NA motors. 2,000 flywheel is possible. We have a car going way north of 160 in the eighth with a stock iron block. I making the power I don't think is the issue. I just don't know how long it lasts. I think that his wasn't an aluminum block, right? 2,000 on a stock block is not going to have very many passes in, I wouldn't think. I use stalls now, and then my Turbo 64 Impala is running 3,500 to 4,000. Gary has a free turbo training course if anyone's interested. Gary has lots of good stuff on their website. BorgWarner, I think, does too. Does BorgWarner have the match block? Richard, what's up? I found out AutoZone sold me the wrong ECU for speed density for my 89 GT is a MAF car. They'll sell you anything. Yeah, you got to kind of know your stuff when you're going there. Ask a Texas no prep racer how much you can lean on a blown LS. I'm familiar with what they do. But how much a stock block, how long a stock block lasts at 2,000 RPM is it's not going to be very long. I think there's any stock block that can handle 2,000. Well, are they doing that with the Coyote stuff? Didn't I see the hotshot Coyote guy making? Somebody's saying 3,000 horsepower, but I don't think that was a stock one though, right? That's like sleeved and all that stuff. Realize there's no way. There's too many variables for the exact math. Yeah, I don't think you'll get it from simulations. You have to get it from testing. I don't think that that's going to happen because I don't think it tells you everything. There's no way that you have all the data without actually having it in the car and having all the data. You can put in whatever numbers that you want, but you don't know that exact chamber sensitivity to detonation. Do you have any safe boost level or horsepower level on 93 octane concerning LS aluminum head motors? Take a look and see, Chris, at what Nelson's doing. He has a lot of pump gas stuff that's fairly high horsepower on pump gas. I'm really glad you said that sleeving a block is cheating. I don't know whether it's cheating or not. I just know it's not stock. If you a stock block is a block that you went and got from the wrecking yard and maybe you surfaced it or whatever or honed it, that's still stock. If you machine it and put sleeves in it, that's not stock anymore. There's no that shouldn't be any sort of opinion. That's definitely facts. So if I heard right, if my engine is 550 NA, it will be okay with 300 or 400 shots. It should be able to process that, yeah. I'll have all 8 cylinders sleeved. Okay. The nice thing about putting sleeves in it, like we did on the LS6 block, the aluminum LS6 block, is that we can make a bigger motor, and then we can make more power because the motor's bigger. It's no longer a 5.7. In that case, it's an LS6. Now it's that was a 468, I think we did. Yes, Nelson does. Tom Nelson's a good guy too. He's good people. And he does use alien technology. That's right. And if you can balance the I'm guessing, I haven't talked to him. I'd like to go see him. I don't know if they're doing softening the chambers. I would imagine that they are. But if you balance that and compression and timing and intercooling and boost level with that sort of pump gas, I think you could do some pretty big things. Obviously, he's doing 4-digit power level stuff on 91 or 93 octane. So, and he's doing it. He's also smart because he's doing it. I think those combinations, I think, are bigger motors. I don't think they're 5.3s. I think they're 427s. And so, having the bigger motor, make more NA power without a lot of compression, it just makes life easier, I think. I think if you make an 850 horsepower NALS, it spins at 9,000. Keep RPM around 7,000 to 8,000 before shifting. You don't really need to push it, then rev it at that 7,000. It will last. An 8,000 RPM LS that you build is still, in my opinion, you guys wanted opinions, is never going to be as reliable as a factory motor is. An 8,000 RPM motor, even like at a NASCAR level, that's not a motor that you would want to go drive. Like, you wouldn't want to go take a 9,000 RPM cup motor and drive it around for 300,000 miles. It's not going to be good for that. If it doesn't pass the dye test, it must be sleeved. Is there significant gains in mile per gallon tuning only for fuel mileage? I have a 4.8. I'm resurrecting the lean cruise ECU that was offered in Australia. Yes, that's where you get your gains from. Are from doing optimizing the tune under those cruise conditions. So I had a Civic VX that would do ultra lean burn. So it would run 19-to-1 under cruise, under specific conditions. And so it would get real good fuel mileage. But part of the problem with ultra lean air fuels is that it's not a very homogeneous mixture. And so getting it to ignite is hard. And then getting it to get even kind of burn is hard. And the way that they do that is with mixture motion. And so you can either have, they do swirl inducing by a number of different ways. The way that the Honda guys did it is that in that mode, they would open and close their the two intake valves of their 4-valve setup. They would open and close them at different times. So it had different cam loads. Because they have VTEC, they could then have the good cam lobe that would make it be a performance-oriented motor, or not. They made it be a regular motor and then an eco motor when not in VTEC. But they would open and close the valve so that they would induce swirl. Sometimes they do it like Ford does it with a swirl vane, where they're covering one of the ports. You can do it in different ways, but that helps with the lean cruise. Just not just getting it to be, lean, and also you might have to adjust your gap, the spark energy. Always Magnaflex your box. If you want RPM, the Coyote's a better choice. Is a push rod length the same on an LS 5.3 and a 6-liter? Yes, the factory push rod length is the same. I'm interested to see how long Kyle's MR2 with a stock K24 block will last at 1,490. That's a lot. That's a Honda block, though. Those are good. Is his block sleeved or anything? Aren't the sleeves stronger than the cast iron block board out to 40 over when one cylinder is cracked? So all 8 are sleeved and board to 30 over. Should I just sleeve the cracked cylinder? It's going to be more expensive to do all of them. But if you are going to do all of them, I wouldn't go 40 over on all of them. Just go 30. Or if you're going to sleeve them, you just go standard bore. And then you'd have more strength in there if that's your concern. You got to balance the concern of the strength with the thickness versus the power output. Because if you go bigger, you're going to make a little bit more power. Although if it's a turbo motor, the difference between a 350 and a 355 is like negligible. We had a set of 862 heads, hang the valves open, shim the heads, and all was good. You put shims under the springs? Is that what you're talking about? So you put more spring rate in it? Richard, do you have the program to run a dialogue? If I were to shoot you my dialogue, can you take a look at it, make sure that everything is running in the safe zone for 5,000 miles? I wouldn't have any idea looking at, because I don't know what you're, I would have to see what the thing is doing while it's driving to know what the air fuel is while you're driving and what the timing is. And also, I'm not a tuner like that. I don't do that. I would just have to show it to Eric or Ish. I think he got tired of blowing him up, the billet blocks and the cost of replacing them. I think his mistake is he's using aluminum rods and never changed them. Oh, did he have a lot of cycles on them? Should I leave my stock pistons and rods on my 6.2 L92 or should I forge them? I'm planning on installing an LSA blower. You should at the very least do ring gap, and then you can run boost on that L92. We've run that on lots of L92s, on LY6s, on LS3s, all of them. As long as you put ring gap in it, you can run boost on it. I don't know how much you're trying to run. An LSA blower, unless you have it really, really hopped up, is not going to make a ton of power anyways. So that motor, a stock bottom end with ring gap, should be able to handle whatever you're doing with the blower. So he was running 1400 plus on a lot of runs. Yeah, I don't know what the cycle life is on an aluminum rod, but I've never tried using them. Richard, you need to read plugs or hit the dyno DF. Is that from somebody else? Richard, in a stock bottom end application, pushing the envelope, let's say beating Capizzi. that's a tall order. Ported 706, ported 243s, or ported uncut 317s, and why? I wouldn't pick any of those heads to do that. Let's giving a 408 kit with the pistons already balanced. Cool. That's why you went back to 30 over. Yeah, that's good. None of those heads are what I would use to try to go as fast as he's going. A stock bottom end is fine, but I would put real heads on it that have much more deck thickness. We had to use the factory head since he did it to keep it fair. I don't know that I've seen any data that shows one of those heads in extreme ported form being better than the other. Maybe I would pick the 243s, but I don't have a reason for that other than I don't think that the head that you pick there is going to stop you from doing it. Your power is not going to come from that. Your power is going to, he's pretty good with the cams that he's using. And he's really good at tuning, I think. And then the turbo stuff is going to be where the power is. An 81 C20 HD 454 turbo 400 14 bolt full floater. What's the max safe horsepower per street? I don't know how to answer that. The max safe horsepower for street is not a thing. You just tell me how much power you want, and then everything that you do to add power is going to reduce the longevity of the motor. Guys might argue with me about that, but if it's not stock, we know what stock will do. All the things that you do beyond that are going to make it not stock. So at the very least, the chance of it not lasting longer has gone up. If you put a 4-barrel intake manifold on, the tune's right, it's probably still going to last the same. But as you go up in power, you're going to go down in reliability. That it has to be that way. So you have to decide, where do I want that trade-off to be? Slap a cam and turbo on there. And Capizzi stuff didn't happen overnight. he made a lot of pulls. He's a pretty sharp guy. House motor sleeve, fire ring, dry deck. Or funny people are calling it stock block. Yeah, that's not stock anymore. And I don't know why. I thought that somebody said it was a Honda block, so I just thought it was a stock block. But I don't know why people try to. If people do, I don't know why they try to pass that off as a stock one. That's not stock anymore. A stock block is a stock block. It's either a stock block or an aftermarket block or somewhere in between there. And you don't get to keep saying that it's this over here when it's closer to that over there. Think I'll be pro charging my 6.2? You can do that. Can a harmonic balancer extend the life of a big horsepower engine? Yes, I would say yes, it does. I would say it can. I don't think it's a guarantee. I have broken a few stock dampers, but again, I'm using Rick and Yard's junk, so you don't know how long it's been on there, what's been damaged or whatever. But we have had a couple break on the dyno. I've never broken an ATI damper. But again, we're not running them for a long period of time. We're getting long period of time engines already and then running them. Talik, you want 600 horsepower? Are you going to run boost on that thing? Is it a carbureted 454? Is it 81? Do you want it carbureted? Do you want it a blower? Do you want a turbo? So saying my 408 won't last as long as my 360 did as a daily driver with racing it twice a month at Irwindale. I only go 500 horsepower on a 454. My concern wouldn't be how long it's going to last on the 454 question. My concern would be, what do you want it to do? Like, how drivable do you want it? That would be my concern. Because you can make power, put a bigger camshaft in it, put port heads. How much do you want to spend? And then how drivable do you want it to be? The camshaft is going to kind of determine the personality of the motor. Do you want lots of power production up to 5,000 RPM? Do you want it from 5,000 to 8,000? You know, where do you want it? That thing is going to determine like how enjoyable the motor is. All right, Chris, we'll see you later. Is WV West Virginia? Does temperature have a considerable impact to back pressure? Like engine temperature? A good 454 will deliver 600 on the street. I'm not a good drivability one. But boosted one will definitely be easy to do that. Poor man's Pro Charger electric bouncy horse, bouncy house air pump. Telling you slap a turbo and a cam in there. Yeah, for a 454, that's what I would do. Cam and springs, and then add boost to it. You add a turbo on it, and you'll be happy because it'll make a bajillion foot-pounds of torque, and it'll make all the power that you want, and you'll be happy. And on that note, for tonight, it is time to go, but I will see you guys all in the morning.